Yeah, I think we can still wait a little bit for the people to come in. I see that some people are joining us today. So we're just gonna wait for more 2 or 3 minutes for the audience to raise a little bit, and then we can start, okay? Just gonna wait a little bit more. You guys feel free to get a cup of coffee, some water while we wait. Just one more extra minute and we're good to go. Okay, so I think we're good to go right now. Hello and welcome everyone to this session. This session is going to be completely in English. My name is John. I'm from Lean Sales, and today we have here Alexandre Del Rey, which is from I2AI, and we have Matt as well. He's from Press, and they're going to be talking a little bit about explainable AI today. And I'm just going to quickly introduce and talk a little bit about the ERA AIoT, which is a knowledge trail. And what is this knowledge trail? So it's basically a trail of events that covers topics from artificial intelligence up until Internet of Things, which is developed by Bosch through Connectory and the support of other companies as well in the ecosystem. The goal is to provide an end-to-end educational experience for all these audiences, which is going to cover research institutes, startups, corporations, universities, and innovation hubs. And also, besides only talking about educational point of view, we're also covering business and technical point of view to generate business and engage with the community. And basically to promote the AIoT knowledge to this community, generate connections and relationship between the participants and also new business opportunities. And some of the sponsors that we have here are AWS, Bosch, CPKD, Intel, Lean Sales, and Lenovo. And the supporters, we have Abinki, Facens, PUC Campinas, I2AI, and Arca. And now I'm gonna pass the word on to Alexandre. He's gonna quickly introduce himself and also to Matt so that we can start this webinar, okay? Thank you so much.
Hi, it's a pleasure to be here. And it's very nice to have also Matt. I will introduce him very shortly. First, I would like to present I2AI. For those that doesn't know, I2AI is an association that connects people business, research centers, government, to enhance the usage of artificial intelligence technologies. And if you want to know more, you can also go to our website. Is there's one in my background here, i2ai.org. You can also in Portuguese, i2ai.org. And there we can find many different companies, many different contents related to artificial intelligence. And I'm pleased to have here APRE. APRE is one of our company associated with us in I2AI. And I'm also pleased to have here Matt Wayne. Matt Wayne is the founder, one of the founders, and also the CEO of Apri. That is an amazing company that are providing explainable AI as a solution for many of developers that need more insights of what is going on in their models. If you never heard about explainable AI, I think that Matt is the right person to introduce you to the topic and also show what is possible to do with these amazing technologies. Matt, I will let you present yourself in more details and let you give us more knowledge about this so interesting topic that I'm sure that everybody will enjoy.
Obrigado,
Please go
Alex.
on, Matt.
Yeah, thank you guys. No falo muito português. I will try to speak very slow in English. If anybody can't understand me or if I'm speaking too quickly, feel free to raise your hand in the chat. I've asked Alex to kindly, tell me to slow down or to shut up at certain points. And so I'm happy to make this a conversation. I'm happy to speak as, slowly and as, exquisitely as I can. But if I happen to go off track, please let me know. I'm going to go ahead and share my screen. So if one of our nice friends can let me know if we have it. Now, this is a deeply technical topic. The topic at hand today is explainable AI. So not only are we going to have to talk about AI, which, artificial intelligence is, a scary topic, but we're going to have to talk about how we explain these models. Now, for anybody in the group who's non-technical, put your fears aside. I will certainly dive into, the explanation of what is this technology and what does this do. But even more importantly, what I want to highlight today is really how these decisions, decisions made by these algorithms and the technology of explainability can influence the way that we improve ourselves, our decisions, and our way of life. So what is the cost of unexplainable AI? Now, this is a very personal example. What if your family wasn't able to buy a home? Now, there are examples in market of, algorithms that were biased against certain groups, and a group like JP Morgan, which is one of the largest banks, financial institutions inside of the United States, was actually fined $55 million for a mortgage discrimination complaint against their lending algorithm. Well, what if you missed out on your dream job? Now, Amazon, one of our favorite companies to deliver us all our nice Christmas packages and paper towels, Amazon had to scrap a secret AI recruiting tool that showed bias against women. There are litany of examples of the ways that algorithms are being used today that are affecting our decision making. Because AI will drive 85% of our decisions by 2025. This is not a thing that we can ignore. We are releasing these algorithms that are highly performant, that are impacting people's lives, and we cannot ignore the fact that it's going to, if it hasn't impacted you already, that it's going to impact you in the future. Now, on a positive note, we do have solutions. One of them happens to be explainability. We're going to get into that today. Hi, everybody. My name is Matt Wade. I'm the CEO and co-founder of Apre. I've spent my career building technologies that try to improve individual human decision-making by augmenting it with AI. We do produce a product at Apre that helps companies explain and improve model decisions. I won't talk my own book today, but if anybody is curious, you can reach out to me at matt@apre.io or, read the website while we're going, www.apre.io. Now, let's make something perfectly clear. All right, for everybody who's technical, non-technical, a student in the room, I am not a scientist, data scientist, ML engineer, PhD, MS, AI whiz, futurist, startup bro, none of that, okay? What I am is a practical individual. I've spoken to hundreds of companies over 10 years of a career, interviewed hundreds of AI professionals, collaborated with some of the best to build solutions in explainable AI that make business sense. Now, this is critically important because there's lots of these technologies that we can release into the market that don't make business sense, that are very hard to understand, that don't take advantage of the expertise of individuals, that don't facilitate collaboration. Now, we're going to break these pieces down and have a conversation about why they're important. So what the heck is explainable AI? So this is my definition. I'm sure that you can find endless on the internet. As I was doing this, I realized that there were probably 50 definitions, but this is one that I think is probably the most accurate. So we're talking about a statistical measure used to weigh the importance of model features. Now I need to break this down for everybody. I understand there's a little bit of jargon in there. So let's break it down. So a statistical measure. This is just, everybody, went to math class and maybe some of us learned statistics. It's just a summary of how, an individual variable, is really mathematically important. So we're going to do a statistical measure. And we're going to weigh the importance. So we're going to take this statistical measure and we're going to put it on a scale. And what that scale is going to allow us to do is it's going to tell us what's better and what's worse. And with this scale, we're actually going to be able to judge the attributes of a model. Now, in machine learning, I'll just pause here right now. What you're doing is you're actually inserting data into an algorithm, and that algorithm is going to come up with a decision. Now, all of the attributes that we feed this algorithm, those are called features, okay? So if you hear me mention features, variables, attributes, those are the qualities that we're talking about. Those are the things that are actually training an AI model. So when we talk about weigh the importance of model features, we're actually talking about the attributes, the hard data that was used to train a model. So let's put this all together. So what is explainable AI? Well, it's a summary of the individual variables ranked for the contribution of the attributes in the machine learning algorithm. So it's a summary that ranks the attributes used in a model. Pretty simple. Now, feel free to raise your hand if we have already confused you. I'm happy to dive into a little bit of detail on explicitly the definition here, but we're going to talk about a few examples and we're going to get to sort of the details so that everybody is perfectly clear on what the technology is and then how it's used. So this is an example, and it is from the application that we create, but this is called a feature importance score. And within all the technologies that we're going to talk about today, really this is the crux. This is the important part, is that you're going to have the features that led into the model and you're going to weigh their importance. And what you'll notice is the bar chart on the right, that's this scale that we were talking about. All of this list of attributes on the left, well, those are the features that the model was trained on. And if I asked you what is the most important one, well, you could look at the biggest bar and say, maybe we're talking about this mean transaction value. And then maybe we were, what's the least important here? And maybe it's the first scene. So what we have on the left-hand side are the columns of data, and what we have on the right-hand side is the feature importance. So I'm going to pause there. This is an opportunity for you in the chat just to stop me, because what I'm going to get into next is a little bit about how this is used in the technologies that are used in market. So what's the problem? So we've been given all of this deep technology, all of these nice things, and we've been given all of these attributes and all of the statistics. So what the heck are we supposed to do with it? What do these actually point to? And so in this example, do we see a problem? If you look at the top most contributive features here, you're actually looking at gender-specific features. And if you remember the example that we led with at the top of the conversation, those companies like Amazon were biased against certain groups. Well, in this specific algorithm, we're actually looking at, and I know it cuts it off, but number of transactions where gender equals female. That's the most important. The third most important is where people are male. And the fourth most important feature is gender. And so here we have an example of an interpretable algorithm where we can actually judge the importance of those decisions, and we can actually begin to have a conversation with the group. But these are the feature importance scores. Now, there are tons of ways to interpret algorithms. I swear there's a new white paper every day that talks about the interpretability of the algorithm. And so let's just talk a little bit about some of these options that are very popular in market, how they're used, and really sort of their importance inside of the ecosystem. So inside of explainability, there are lots of methods, there are lots of methodologies, there are lots of ways, like we've already said. So 3 of them are exampled here, and I would say that these are probably the most popular that you could find in market. You have SHAP, and that's what I've shown you in the previous slide. These are Shapley values. And so Shapley is really a game theory model. Imagine that you're doing a sensitivity analysis of your data, and you're figuring out how much you pull something, how much does it affect another variable. So imagine if you decreased, the number of transactions that somebody had, how much might that affect another variable? That's really what SHAP is trying to do, and that's the statistical measure that is taking place. So it's an It's a post hoc measure. So what that means is that after you've created a model, this is when you get the explanations. So as you can imagine, as practitioners of AI or business individuals, you've created this model, it's making decisions, or it's in the lab making decisions, and only after you've created the thing can you actually explain it. And that's the case with all of these technologies here that are extremely popular, but this is the analysis that it's doing. It's doing a post hoc, which means after the model, after the decision is made, analysis of the model itself. And it's used to analyze the magnitude of feature importance. And so that's really what we were looking at in this slide again, is the magnitude of the feature importance. Now we have another technology, which is called LIME, which uses a surrogate method. So what you can imagine is they're creating individual models based on features, single features. So features are columns again, and it's judging the importance of that feature against the output. And so if you had 100, features inside of a model, it would create 100 surrogate models, and it would judge how that feature really was correlated to the output. It's not quite correlation, but that's a good way to think about it. It's also a post hoc measure. Now, the thing about LIME is that it's very good at looking at text. And so here we're going to talk a lot about structured data, because that is, around 50 to 60% of the market. But LIME is very good at doing unstructured data and semi-unstructured data like text. And so if you had a chat bot and you were trying to understand entities in a chat bot, and entities being, nouns, verbs, things that are important to the conversation, LIME would be a fantastic tool that you could use. And then we have integrated gradients. And integrated gradients is, again, a contribution method, sort of akin to SHAP, but it's looking at the gradient or the descent of a single feature. And it's used to, analyze images, text, structured data. It's highly efficient. This algorithm was developed by Google or, scientists at Google. It is a very popular methodology as well. Now, within explainability, there are advantages and drawbacks to all of these selections here. For SHAP, imagine having to, create every permutation possible for every output of the data that you give it. Well, that's kind of what you're doing with SHAP. And then for LIME, imagine that you're, having to create models for every single feature, within the data set that you're given. And imagine with integrated gradients, you have to do a gradient descent model for every single feature that you're looking at. What you end up getting is highly inefficient methodologies to really explain what's happening within the model itself. But they are super, super important, like we've already discussed briefly. And so it creates this trade-off within businesses where sometimes they ignore explainability because it takes a lot of compute, it's really complicated, and oftentimes, how does it improve the communication between teams? And we're going to talk about really some of the tools and methodologies used today. But there are trade-offs and advantages to each of these. Within the company that we run, we use Shapley, and we run a Monte Carlo sort of simulation on the largest data sets that we would see. But we also do sampling, and that can give you an approximation. When we were doing text analysis, LIME was a good choice for us. We would use a composite between the two. And integrated gradients, I think, are fabulous for images and provide an efficient solution for images. So it ends up being sort of the best tool can fit the best data set. So I've shouted at you a lot about technologies and ways that this is influencing the market. So why does this actually matter? The AI that we are deploying today will impact your working life, your personal life, every facet of your life. And when we look at the models that are used today, it's really hard to answer questions about how we are meant to interact with these things. If I mention AI in 90% of the rooms that I ever go into or a cocktail party, people are like, unless I'm in Silicon Valley, people are, kind of put off and they're scared by AI because they don't know how to interact with it. They don't know how to answer questions. And this isn't limited to, just AI people are special. This is extended to the entirety of the organization. So from the regulatory perspective, they have no idea how to regulate this stuff. And so, when you look at Europe and when you look at, even Brazil, and when you look at America, we're talking about sort of the Western world. The regulation that's coming in is really hard to figure out. How do you manage an algorithm when there's so much variability? And then from an engineering perspective, you would expect that all of these engineers are fluent in all technologies. And if you're competent in one, you're competent in the other. It's just not true. It's very hard to imagine how you can monitor something that, again, has so much variability inside of it. And then the non-tech crowd, which, frankly, I introduced myself, I fall into. How do we justify these decisions to people? If you're giving a decision and it's impacting somebody's lending or mortgage or lifestyle, how do you really, feel comfortable giving that decision? And even from a data scientist perspective, even, our own scientists, if we're doing something in lab or we're experimenting with stuff, answering the question, how exactly is this system functioning, takes heavy amounts of software and expertise. And so AI today is going to impact every part of our working lives, from technical to non-technical. Now, the scariest point of view is the one that we've already discussed, which is the customer, the person on the receiving end. Now, if you've ever, downloaded Facebook or been inside of Instagram or, watched a Netflix show or searched on Google, you are impacted from AI every day. It's dictating the news that you read. It's dictating the things that you watch, the friends that you make. It's already pushing you in certain directions. And frankly, we should start asking ourselves, why did I get this decision? And how can I trust this decision? And that becomes a really complicated question to answer. And so why should we care? Because AI is already impacting every decision in your daily lives. And it becomes critically important for us to be able to answer questions like this, where we can actually begin to collaborate with the model and begin to answer questions about how it's impacting our lives. Now, when people like the European Union writes white papers on, what's important about white box models or what's important about explainability, they need to, from a regulation standpoint, trust that the outcomes are fair. And they've recommended a combinatorial approach that takes into consideration explainability technologies and expertise from humans, because they understand that this collaboration is inherently needed. If I gave you those statistical measures that we've talked about at the top of this conversation, a lot of you would turn to me and say, I don't understand the difference between, what is, the second and third and fourth and fifth. Are they statistically very different in importance? How am I meant to judge what is important and what is less important? It's very hard to understand. And so even what the EU has called for is more of a, conversation around how do we take explainability, that statistical measure, and integrate it with expertise. They call that a symbolic model. And with these, white box models, you can actually tell engineers, because if we do point an engineer in that direction and they do understand statistics and things like that, they can actually begin to have a conversation. And even non-technical individuals, even asking the question that I just posed, what is the most important? These things don't look like they should be so important. Let's start a conversation there. We can begin that conversation with a model. Whereas today, when you're just given a decision like this is you should be watching Stranger Things, or this is the top, search result that you have, you don't necessarily understand the context behind why that was given to you. You don't recognize that it's because you searched yesterday a certain thing, or this person's connected to your cousin, or you just watched, Stranger Things 1, and now that's why they're giving you Stranger Things 2. It's really hard to understand that context. So it becomes critically important for companies to begin to bridge that gap, because then you can actually collaborate and say, I don't want to watch Stranger Things. I don't need this search result. And you'll notice some of these mechanics within Google, and you'll notice some of these mechanics within Facebook and Uber and other large companies where they take that feedback. And that's actually used in their training and their model process. From a data science perspective, they can trust the system when they have these tools. At the end of the day, what's critically important is that stakeholders, internal users of these applications, and most important of all, customers, understand and trust why the decisions that we're giving them are made. Because finally, if we have an interface into these models, we can actually have feedback into why they're making decisions. Again, if I showed you what we just went through from on these statistical measures, you would be able to bridge that gap and talk to me about, why are we talking about gender at the top of the, inside of explainability? Why are we really looking at these factors as the most important? That doesn't seem right. Maybe we should exclude those and run the algorithm again. There's this dirty little secret about AI, and let's just pause and let's talk about it. Models do 98% of the work when it comes to really, doing everything that it's going to do. we give it data. It takes a terrible amount of time to go through that data and make sure that it's exactly right. Any of the AI practitioners here can sort of point to, it takes 80% of an individual's time to really comb through the data, to, clean it, prepare it. But once we give that data to a model, that model is going to train, and that model is going to come up with its own outputs. And of course, there's a little bit of engineering that goes into the model to, figure out, how these variables should be weighted and things like that. But generally speaking, the model is going to come out the other side with a result. And so if the model is doing all of this work, if it's doing, the gross majority, let's call it, 51%, who cares? What are the people doing? And the people are oftentimes just data scientists who are interacting with this product, who built the model, who are, invested in its success. But the fact of the matter is that these questions can be raised by anyone given the right tools. And it's not that hard to retrain the thing without these variables, or to try something different so that it doesn't have that kind of outcome. It is really very simple, because again, the algorithm is going to do the work. And that's the dirty little secret here, is that the data is the hard part, and getting the data in the format is really, that's kind of the hard part. Picking the algorithm, engineering the model, that's sort of a second tier concern. And then, editing these things through time, not that complicated. So if we're only able to give these statistical measures to the people, we can begin that conversation. And like we've said, maybe we shouldn't be valuing gender as much as we are inside of this model, and maybe we should exclude that. And that could be a point of collaboration for the group. Now, when we look at models, and when we look at the model lifecycle, model-centric options really limit you. We haven't really gotten into, what is the difference between global interpretability and local interpretability, and, all of these sort of different factors. The fact of the matter is that you really only have two ways of measuring results very concretely. You have global explanations, and global explanations are really how an entire model is behaving. And so if you wanted to know if a model was biased, or you wanted to understand, what were your most important variables in the entire model, you might use something like a global explanation. And that global explanation is going to provide you with, all of those statistical measures that we've just gone through. Even here, let's go back one. Even here, these are global SHAP values. So this is looking at the model in its entirety. And it's telling you what is most and least important inside of the model itself. And so it's how the entire model is behaving. And then you can go down from, imagine you have millions and millions of decisions, and you can go down to one single decision, and you can explain that output. And so we're able to explain on a decision basis, what are the most important sort of characteristics inside of that single decision. Why that's important is because when you're making decisions, at the end of the day, if we give you a decision and it says, this is the loan score, or this customer is going to churn, or you should buy Pop-Tarts, the feature importance, the actual variables that went into that feature, we can actually understand, examine, and give to customers. And so that becomes critically important. What we're missing is the entire valley in between a single and the absolute maximum. And these are model-centric options. And so we focus now on, how explainability works in practice in broad strokes for the entire market today. And they focus on the model. And the model is important because the attributes of that model are what we want to judge, right? And we would think that that's critically important. But like we've said this entire time, we're trying to bridge the gap between, this technical piece of an algorithm and the rest of the organization. The rest of the organization, you as individuals, you run off data. And so how do we close this gap? How does the model explain your business reality? And the fact of the matter is, you need to know who your best customers are. The explainability is not going to give you that. You need to know why you're having an error. And of course, explainability can help you a little bit with that. You need to understand groups of customers. It's great if I can explain one prediction, but it'd be great if I could explain batches. Or what if we have time periods like, the last 30 days, or the last year, 6 months, 2 weeks, 12 hours? How do we explain these characteristics? This is what makes business sense. I need to know why my customers churned more last month. And of course, there's analytic measures, there's all these other things, but why did the model think that I was going to have, 10 people churn, and I actually had 100 people churn? That's a really hard question to answer with current levels of explainability. And if we want to bridge that gap between technical and the business, we have to take into consideration beyond what is a single decision and what is the maximum, global vantage point. And we have to fill in all those gaps in between. A data-centric approach provides that missing context. If you guys as individuals really boil down your expertise, it's data, what is in our minds, the way that we make decisions, what we gather every day, the way that we talk to people, the way that we actually communicate from a business standpoint is using the data, the experience that we have. So a data-centric approach, you can actually think of as a human-centric approach. It's filling in those gaps because we can actually take the data that humans understand. Excuse me, I've got a bit of a cold. We can implant that in model decisions. So we can actually analyze this information, we can add that expertise, and we can give it back as data. And like we've already said, the data is going to be used inside of the model, and that's actually the hard part. So if we can give it better data, we can give it our expertise, and that's going to go and train this model in the direction of what we believe is true. How empowering is that? And so when we really break it down, we actually have a few tools, a composite of tools that have to be used in order to bridge that gap. You have explainability, that is going to be the statistical measure. You need that because you need to know how the heck your model is behaving. But you also have to use the data in order to interact with that information and impact the business itself. So how does Netflix know that you should be watching Stranger Things or the Cooking Channel or the, if you were my wife, the home rebuilding shows? How do they actually know to recommend you those types of things? How does Facebook know that your first cousin is your first cousin? How does Google know that you should be clicking on this link and not that link? How does Uber understand sort of, the buying habits of individuals, Amazon recommending packages? They use GNNs. And GNN, that is a nice acronym. We're going to get into it for a second, so don't worry. They use GNNs to analyze your user behavior. They all use this technology, okay? So the best companies in the world use this technology to understand user behavior, because they understand distinctly that if we stay at a global view, and if we stay at a microscopic view, you're going to miss all of the nuance in between, and we're not going to be able to make business decisions. Now, GNN stands for graphical neural nets. They look crazy, okay? And if you've never seen a GNN before, these dots represent customers, and as these dots are closer together, that means, and it could represent customers' products, but for the sake of this conversation, let's just pretend they represent customers. As these dots get closer together, that means they have affinity. This GNN is a model, and it's actually trying to predict the relationship between your customers or you or your products. They're trying to predict affinity, and that becomes really powerful because all of a sudden we can combine these two technologies. We can look at users, products, etc., and we can look at how the model is actually interacting with the data. Does the data relationship match the model relationship? And where are those conflicts, and how do we reconcile those? And so what you have inside of this is a contextual look of your information and your model, okay? Now, I know that we've gone through a few technical concepts here, but bear with me. So we've talked about a model, and a model takes in that data, it's making decisions. We all sort of have a cursory understanding of AI, at the very least. Now, when we're explaining that model, we're explaining it based on, all of these statistical measures, how that model is behaving and what it's doing. Now, at the end of the day, the way that the model is making this decision is going to result in a customer, having an outcome. So let's take this fraud model, and let's say that we're trying to see if a customer is going to be fraudulent or has been fraudulent. Now, you can apply this or extrapolate this to any decision that you need to make. Or is a customer going to churn? Should a customer buy a new product? What is the credit limit of an individual? Etc. You guys, it's endless to the conversations that we could have around that, but it's a measure of, you can make any kind of decision, and this data can project out those decisions. Now, these dots, those are going to be your users. And so for those paying attention at home, the right side looks a lot like fraud, and the left side looks a lot like non-fraud. And that's really good because the model has learned a behavior that is present inside of the data. The model and the data actually agree. And so that context is going to make sense, and it's going to be a sticking point. And again, this is how Netflix and Google and all of these sites begin to understand behaviors, because if you're represented by the little snake on the right-hand side, maybe you're the end of the snake, well, there's about 10 other individuals inside of that snake, or 1,000 individuals inside of that snake that are very similar, have similar behavior to you. And so we can begin to recommend and associate behaviors with each other. And as you can imagine, when you're getting into making decisions, or when you're getting into trying to, add context to business decisions, understanding relationships between, or, counterfactuals, or the relationship between your customers actually helps build context. If I can say, you're watching Stranger Things because all these other 10 people watched Stranger Things and they really liked it, and you've watched all the same movies that they've watched, it begins to make sense. And this explanation for why the model's making a decision, this statistical measure is great, but we can actually boost that and say all of these other people also behave like you and they had the same result. Now, what this technology affords you is to be able to, look at overlays. Like before, we were looking at gender, and we wanted to know if gender was biasing the decision-making process. And here it's a little bit of a muddied graph, but here we have, really a lot of males, and males on the right-hand side. We have a pretty even distribution for not fraud. But maybe, we need to take a closer look at the data itself, and maybe it isn't, 50-50. And so we could do an analytic on top of this to understand what is the split of the data, to see if there's, any kind of, feedback there. But it looks like there's a pretty even distribution. This begins to answer that question. We had one statistical measure that said this was really important, but we had male, we had female, and we had gender all at the top. And of course, those gender qualities can't be the way that we make decisions, but extrapolate this to any, feature, analysis, variable inside of your model. And you can understand that you can begin to have this conversation. Maybe we extend this to the number of transactions. If you're looking at fraud and you're trying to understand who might be fraudulent, who do you think really might be fraudulent? Is it going to be the person with the least number of transactions? Well, they can't commit fraud. They're not spending any money. It's going to be the people with the most number of transactions. Well, they're statistically probably more likely to commit fraud because there's just more transactions. And that aligns with the data. And really what we're seeing on the left-hand side, you're seeing a lot less transactions. And on the right-hand side, you're seeing a lot more. Now, this is sort of off the beaten path of explainability, right? Traditional explainability. But let me bring it full circle. So the features that are used inside of this model, the explanations that are given to you, well, that's a statistical measure. That's really allowing you to see importance at a global level, at a prediction level. When we want to deep dive and we want to understand this context around why these decisions are made, we actually want to begin to analyze, is gender important? Where is gender important? How does gender sort of make, add to this model, subtract from this model? Or more practically, because that would be excluded, how do the numbers of transactions, the behavior with this product, how does that actually influence transactions? And does that align to my expertise? Now, the power of this type of technology is if you did or didn't like something, you could come in, you could begin to add data to a model like this. And just let me pause here. I hope that this is perfectly clear, and feel free to raise your hand if this isn't perfectly clear, but all of these variables are present inside of these GNNs, inside of these technologies. It provides you an overlay of the look of the data. And what we as scientists or practitioners or individuals try to use this technology really to do is to bridge that gap between what is very technical and what is very practical. Because we relate to people, customers, products. A scientist might relate to statistics and measures and numbers. We relate to, tactile things as non-technical, and they relate to more technical things because they're developing the model. This is a merging of those two qualities where we begin to have a conversation about why things are important and why they're not, and how we actually make business decisions based on this information. So when we're analyzing a group, let's say that we, wanted to figure out why the heck these people are fraudulent, we can look in and we can actually begin to get, a new measure that looks a lot like explainability. And we can start to understand, the ways that income influences this, or the way that, transaction volume influences this. And I know this is cut off, and I apologize for that. Screenshots late at night. But what we have for us are a list of features, and we can actually judge the severity, the magnitude of that information inside of, these cohorts. We can actually begin to make business decisions based on the data. We all drive based on KPIs in business, and that's another quality that we can really build into this. Where do the KPIs fit into the magnitude of this decision making? If we're adding up all of the transaction value, we can actually look at the highest value customers. We can look at those people. We can analyze them from an explainability standpoint, and then we can actually drill down and we can get into single decisions and how they might be made. What this does is it empowers us as individuals to add data into the model. For the first time, we can say, we have our output. It is from the model itself. I understand how it's explained to me because I have all of these statistical measures. I understand the context because I can actually weigh it against, a similar instance or other customers or other products. And I can actually take my expertise and I can influence those decisions themselves. That's the power of something like a GNN. But let's put this in dollars and cents. And folks, we're gonna wrap with a little bit of a perspective on why this matters and how this actually impacts the businesses that we're all a part of, the technologies that we're going to build. But feel free, if you do have questions, to sort of keep them at the tip of your tongue, because I do believe that we'll have time afterwards. But let's put this in dollars and cents. So AI is an enormous market. I know that we've been talking about by 2025, 85% of our decisions will be driven by machine learning models. And, in that time, we'll consume more data than the entirety of human existence before. Individuals, companies are going to be spending hundreds of billions of dollars. 110 is sort of what's projected by 2024. So even the year before that 85% number, excuse me. Now, what happens today is that we develop these models and they have an 87% rate of failure from pilot to production. So this is not an easy thing. When you're building these technologies, going from pilot, which means, a nascent lab-based technology, into production, there's an 87% failure rate. Even if they're successful, there's an 85% instance of error. And then regardless of the outcome, what companies are really spending their time doing is data processing to understand the underlying data to try to explain it. There are inefficiencies all over the place. If you're looking to develop AI, if you're looking to think about it in context of your business, if you're interacting with models in the wild, these are good things to keep in mind. Is that, if you're touching a model, it's one of the 13% of models that have made it to production. Fantastic. It still has an 85% instance of error. So it is going to have errors. We are going to have to live with that. And then even beyond all of that, the team behind the curtain is actually spending a ton of their time just understanding the information and processing that information so that they can try to understand it. It's a horribly inefficient system. So if you spent $100 on AI today, if you looked at all of those statistical measures and waterfalled it out, 14 cents would go to engineering a successful model. And why do we believe that this is the case? Because it's a failure of communication. In model failure, it's really a failure of communication between teams. If we've underspecified a model, if we include gender inside of its analysis, that model can't be productionalized. It's going to fail. Or if it just outright isn't performant because we don't have the expertise from the individuals built into the model, it's going to fail. They're going to have an 85% instance of error. I think I've missed my 87% at the top. I apologize. 85% instance of error though. And maybe this is a miscommunication in the data. Maybe the data isn't exactly right. Maybe we didn't pick the right training set. Maybe we didn't have the right attributes. 80%, on this reporting spend. That is an absolute communication bottleneck. Getting the right data in the right place to the right teams, cleaning it in the right way, absolutely a communication issue. And so how do we, organizations, regulators, customers, the people in this room, communicate effectively with AI models? The only way that we can do it is through accurate model explanations and interpretations. As we've already talked about, the solutions today are really hard. I won't say not useful. I think that might be inflammatory. But they are very difficult to use outside of data science. They focus on model error. They focus on these issues. These solutions do exist. And as you've seen, Amazon, do you think Amazon didn't have explainability when they had the bias in that model? Do you think that JP Morgan didn't have elements of explainability while they were developing that model? These solutions exist and the failure rate is still 87%. In the best case, the solutions give these organizations $2.86 back. So what's the solution? Explanations that promote collaboration between teams. These solutions should empower you. If you have a model in production, you should be asking your data science team, how can I help you? How can I add my expertise into the model? Technology that enables you, the 99%, not these, not just data scientists. We love data scientists. I fake being a data scientist. But truly, we need technology that enables, my mother or the people in this room who are non-technical to be able to interact with these technologies. What we believe is that context is key, that being able to answer business questions with this technology, not just statistics, becomes critically important. And we are building a company, and we do build technology that enables that at Apprae. But we believe that GNNs and the technologies that allow context and people to interact with these models is the future, and that is going to enable sort of a better place for us. So thank you, guys. Thank you for letting me chat in a room, scream at you guys about explainability. I'm here to answer some questions, and thank you guys for the time.
Yeah, was a great discussion here, a great presentation, Matt. I have some questions here. First, I think Heinz are asking, is it possible to get the slides after the presentation?
Yeah,
I do believe this is.
Of course, there are links embedded in those slides, and if anything is not cited and you need it cited, like, I'm happy to give you guys any of the research that went into it as well. This is our bread and butter, so I'm happy to forward whatever information I have on hand.
Okay, I have another question here. This is more related to the topic, not to the access of the presentation. Will AI be accessible for small companies in terms of investing? If not, will they survive the market without AI?
So what's critically important for small companies is to think hard about the data that they're collecting, more important than the model itself. Again, models are a commodity, okay? You can find models laying around anywhere, right? Like, if I spent 15 minutes with a lot of you in the room, we could figure out how to train a model really quickly off the data on my computer. There are plenty of companies that make these technologies accessible. Again, the most important thing is going to be having the data itself, and then making sure that whatever algorithm that you're developing, if it's going to touch stakeholders, if it's going to touch your employees, is actually understood by the practitioners. You don't need to be a data scientist necessarily, but it's helpful. You can always find those touch points, and a lot of these technologies have explainability or other sort of ancillary tools built in. But I would say, yes, it's accessible. What's oftentimes not accessible is the realization that your data is going to really matter. The cleanliness of that information really matters. The format of that information really matters. And so tackling that level of organization very early inside of a small company is critically important. If any of the small companies in the room want to have a conversation about their data or why that's important, feel free to reach out to us. I'm happy to point you in the direction of resources or even, our own application. But I do think it is accessible. I do think that it can have a cost attached to it, like any piece of technology. That cost does scale, but you have to look at the efficiencies of the technology that you have, and it can augment your people to a great degree. It can influence decision making in really positive ways. But there are opportunities in market for smaller companies to invest.
Great. There is some questions here. Onedo is asking if the video and slides will be available. I think the video as well, I will be available. Yeah. Andressa is mentioning everyone needs to understand the AI logical, technical, and non-technical.
100%.
People, it's a
people.
They are talking about everybody need to understand that the model in itself. Great. And Matt, I'm curious because still you have many technologies that are like yours that could help companies to understand better their models. Still, there are many companies that are reluctant, I would say, to invest more in understanding or put more effort in improving their model. They are putting more effort in generating new models instead of understanding it deeper and improving it. Could you mention? Do you have any clue of why it's happening? Why companies are trying to develop new models from scratch instead of understanding their own?
Yeah, so I think that, they're just easy, simple heuristics that we can use. Do we care if our Google search is, 10% better? No, we love that. And do we care why we're getting the first result? I would say, no, we just click the link. And do we care, why we got a better experience on Netflix? No, we don't. But I think that the thing that companies are realizing more than ever is that this expertise from their customers, this expertise from stakeholders, when it can be built into the model and when they can build those types of experiences, these are AI first types of companies. And we try to supply technologies that enable that. But when you start to facilitate a conversation, you get expertise that improves your model dramatically. And so it's really a business case question, Alex. How do we create business cases for these companies to align themselves on an AI first sort of implementation. Now, why don't companies try to tackle these technologies today? It's one of those things. I mean, if you know that you're gonna, it's sort of a there's a thing, a proof called Schrodinger's cat. Like if you lift the box, the cat might be dead, the cat might be alive. If you open the box, like Pandora's box, who knows what you'll find? And so a lot of companies are scared because they know if they have the data, they have to act on the data. They aren't quite able to size up sort of what the concerns might be. And so I think a lot of companies, until regulation comes in, are going to sit there, satisfied with the fact that they have something high performance and that they have a cursory understanding, or at least a trust in the team that's building it. The fact of the matter is that they're leaving performance on the table. And so why we're a company in market right now is to create a business case for these technologies, because not only are these technologies good and help humanity and push us forward, but they actually provide performance for the model itself. And that's critically important for companies to realize. And as soon as that business case is made, Alex, like imagine, solar panels, or developing solar and clean energy was free, everybody would switch to clean energy because it's better, faster, cheaper. And we're trying to provide a similar solution, a similar business case for industry. But I think that people are generally scared of what they might find, Alex. I think that's a lot of it.
Yeah, good point. I'm not sure if they're gonna be scared or still business people are how can I say, let it to the technological guys to do the job, right. And they are not concerned of how they could drive better technology. It's not their business yet. I think that you're going to change, but it's just
we've lived in a world for like the past 20 or 30 years where we've had IT, we've had technical departments, we've had engineers, and they're kind of like off in a different room, and then you have the business people, and they're in a different room. And I think like one of the things that just needs to be realized is that division is going to be less and less obvious as we move forward, because again, the machine is going to be doing a lot of the engineering of that decision making. It becomes critically important for the data, the experts, so the other side of the house, to really play a role in the way that these decisions are being made. And so I agree with you that there is this look that like those are the technical guys, I'm the business guy, and we don't really interact because there has to be like a method of translation. But that gap is closing. And I think that companies, very quickly will realize that these technologies are empowering and can be driven by other people inside of their organization. And again, I think that that's why we're here. But you're exactly right, Alex. And that's the hesitancy to adopt these technologies. It's scary. I don't know as a stakeholder what the heck the thing is going to do. It might be good. It might replace me. I might look like I'm smart. I might look like I'm dumb. I have no idea what the technology is doing. And I think that transparency helps to answer some of those questions, but also just time and education will as well.
Great to know about your opinion about that. Let me see if there is any other question here. There is Fernando here. Don't you think that just check here. Fernando Domingues is asking, don't you think that explainability is more useful for critical applications that affect people's life, like for instance, when they have its mortgage denied, than when they received a bad recommendation for Netflix? Can you comment about that?
Yeah, of course. So I think that it's a slippery slope. Where do you draw the line? What is critical to people's lives? I'll give you an example of a real world example, but I agree that regulation should step in on the critical decisions where we're touching people's lives, finances, health, everything that is already regulated that falls into sort of like under regulatory scrutiny. I agree that, algorithms should certainly fall under that same level of scrutiny and already do today to a degree, but making sure that they're auditable and explainable becomes more important. There's a recent instance where Twitter, just in their visual cropping algorithm, was cropping individuals differently. And it was cropping, frankly, Caucasian people differently than it was cropping, in our case, in America, African-American individuals. So just people of different skin tones were getting cropped differently. And I think you look at that, and that's a very mundane example. But I think that we have so many of these examples of, casually reinforcing, bias in our society. And when it bleeds into our technology and we're accepting of just those differences as the algorithm saw something different, I think that's a very slippery slope. And I think that, Netflix is kind of a flippant recommendation, but what if, it was recommending you, very inappropriate things, and your parents walked in or your spouse walked in and they were like, well, this is being recommended to you. What are you watching on Netflix? I'm sure you'd have a different opinion about how important that is inside of, the conversation with your wife. And so, or husband, or, spouse or individual. And so I think that it is a flippant example to say Netflix, but I do think the responsibility of companies is to add context to really what they're doing. I feel like that's the bare minimum. It doesn't have to be like, flowery and everything, but it has to give you some clue. And then I think if you were able to tell Netflix, and you are able through voting mechanisms, and that's the same thing, right? I like this, I don't like that. This is a 10, this is a 0. That you like certain categories of things, the experience is going to improve. And so that's what I'm saying. It's not explicitly about those instances where, something is good or bad, or I do think that those matter, because in aggregate, they begin to matter a lot. And the data that we put off is critically important, and it reinforces bad behavior. And then for Netflix and things like this, you're starting to see these mechanics bleed into, this as a 98% of you like this, 75% of you like this, and you thumb that up, you're confirmatory, that reinforces the model in the right direction. But I do think that, again, regulation for the most critical things. And then I do think that oversight, or committees of oversight for the less critical things, we don't want to reinforce bias in our society. At least that's where I'm coming from. I know that seems, very flowery, but again, these things are slippery slopes. And I think that it's important that if we're going to have these systems, that we treat them responsibly.
Oh, great. A last question here, Matt, and then I think that we are coming to the end of our time here. But the last question is, I think AI will only be accepted in medicine after greater development of explainable AI. In health, we need to know why the algorithm achieves the results. What is your opinion in this field of medicine, health, healthcare, and so on?
So so first off, exactly right, that like there needs to be, you have a doctor who's an expert. That doctor needs an interface into why algorithms are making decisions. But don't be fooled. Drug discovery, specifically, some of the most critical medicines that we have in our culture today, and some of the most critical medications that are going through approvals steps today, were discovered using the exact same technology that we were just discussing. So they are doing drug discovery using, things like neural nets and GNNs. That is how they're discovering new medicines, new drugs. And it does provide sort of the context and clues and explainability in order to bring those things to market and get it past regulatory scrutiny. Now, if we're making diagnosis, or we're trying to figure out, what part of my arm to cut, I'm gonna want something to explain to me that like a doctor or a human has had oversight into that decision, because these things deal with our bodies. It's the most personal thing. And so I very much agree that we need a lot more influence in those regards. But don't be fooled. These AI is already in place in a lot of markets. I've spoken to the individuals. It's doing tremendous things, and thankfully it's going to save a lot of people's lives. You guys, I know that we're bumping up against our time. Thank you, Jonathan. Thank you all of our kind sponsors for having us today. Alex for being our host and excellent MC. Great to see you. Hope to find you in Brazil soon enough. But thank you guys for having me.
Thank you as well, man.
Great presentation.
Thank you for bringing this rich content. And I'm just gonna quick show the schedule that we're gonna have for the next events. All of these events are going to be entirely in Portuguese, but I've also put the names down in English, so we have the visibility. But on the 29th, we have artificial intelligence challenges and paths with I2AI as well. On the 6th of October, we have a maker event at PUC Campinas. On the 11th of October, we have an event with Intel about building a solution with computer vision. On the 18th of October, we have another event that's taking IoT to a new level through private mobile network with Arkia. And the 25th, which is another event for CPKD, private networks and IoT. And on the 8th of November, we're going to have an event with AWS and Intel about the hands-on. And if you guys want to know a little bit more about the next and the upcoming events, we have the QR code here. Feel free to scan. That leads us to the website. And that's it. Thank you so much for the audience. And we stay in touch for the next events. Thank you so much, guys. Goodbye.
Thank you. Bye-bye.
Thanks, guys.